Hi everyone, this is our final year project Smart Safety Helmet for Coal Mine Workers in Lifi. Objective of our project is to create a smart helmet for coal miners in order to save them from hazardous situations using light fidelity technology in order to achieve high data transmission rate. Existing system. In existing system, helmet is equipped with methane and carbon monoxide gas sensor. This sensor senses the gases and data is transmitted through the control room wirelessly through a wireless module called XB connected with the helmet. When the methane or carbon monoxide gas concentration is beyond the critical level, controller in the control room triggers an alarm and keeps the plant and the workers safe by preventing an upcoming accident, which also provides a real-time monitoring of harmful gases like carbon monoxide, methane and LPG. Disadvantage of existing system. In an existing system, it collects the sensor data and sends it through the Zigbee or in a Bluetooth, which is only suitable for low range of distance. So it is difficult to transform the information at the correct time, which in turn leads to the loss of life, and it also has high security issues. Proposed system. In the proposed project, we are going to implement the temperature sensor to sense the temperature of the worker's environment, humidity sensor to check the humidity, gas sensor to check whether any poisonous gas came out during coal mining, and heartbeat sensor to monitor the condition of the workers. When the informations are gathered, they are monitored by using mode MCU, IoT, etc. The message is also passed through mail. Advantages. The proposed system is done by using Internet of Things. There is no distance parameter for here. It is automatically stored the values in cloud. It is highly useful for the future reference. It also generates alert mail. Literature survey. Topics. Lightweight mashup middleware for coal mine safety monitoring and control automation. Work done. Objective of this work is to provide a safe service mashup middleware to improve the coal mine monitoring and control automation, which allows the user to create the ad hoc safety monitoring and automation service initiatively. Pros of the system. Reduce the cost efficiency to create a coal mine safety monitoring and control automation applications. Cons. It is not efficient for long distance communication. Energy efficient clustering protocol for earlier warning system for miner safety in coal mines. Work done. Wireless sensor network with a gas sensor is used to predict gas burst in earlier manner. Wireless sensor network monitors the toxic gases even in the same environment. Pros. Zigbee is used, which is low in cost, low power consumption, which in turn gives long battery life. Cons. Difficult to handle this process, it has multi-hop delays. Smart helmet for coal miners, safety monitoring and alerting. Work done here is providing a real-time monitoring of harmful gases like CO, CH4 and LPG. Pros of the system. High efficiency. Cons of the system. High in cost. Implementation of smart safety helmet for coal mine workers. Work done here is, it is all about designing the helmet equipped with sensors like methane and carbon monoxide gas sensor. Pros of the system. Wireless transmission of data. Cons. Data are monitored in the lab view format and it is not reliable. Zigbee based intelligent helmet for coal miners. Work done here is earlier warning intelligence on methane, temperature and humidity in mining area, and it also uses speech communication to reduce potential safety problem. Pros of the systems. Wireless speech communication. Con is less scalability. Intelligent safety system for coal miners. This paper uses the Zigbee based wireless supervising system for coal mine is presented. Alerts when there is a hazardous environment using methane, temperature and humidity sensor. Pros of the systems are low cost, low power consumption and comfortable to use. Cons. Only suitable for low range of distance. Smart security system for mining workers using IoT, which provides system for mine workers to identify dangerous gases and location for workers. Pros. Long battery life. Cons. Less performance. IoT based smart helmet for unsafe event detection for mining industry. Work done here is, which could detect quality of air, crash of helmet and removal of helmet. Pros of the system. This system has high human interface. Cons. It has less scalability. Smart helmet using RF and WSN technology for underground mine safety. Work done here is, the wireless sensor network is provided for the sensing of adverse working environment conditions used for an early intelligence warning system with the help of programmed alarm sounds if there is any serious deviation from the normal parameter value range. Pros. Improved safety and improved conditions monitoring of dynamic environment changes in the mines. Cons of the system. Presence of RF waves causes health issues and it also high cost. Architecture diagram. Architecture diagram from the architecture diagram, it is clearly understood that the sensor network, which consists of the sensors like heartbeat sensor, humidity sensor, smoke sensor, temperature sensor, gathers information from the sender, which is coal miner, and the data are transmitted wirelessly, which is achieved by the light fidelity technology, which is commonly known as Lifi, and the data are received by the controller, and automatic calls as SMS mail alerts are created. Arduino. This model has the heartbeat sensor, a humidity sensor connected to the Arduino. Heartbeat sensor measures the changes in the volume of blood through any organ of the body, which causes change in light intensity through that organ. In case of applications where heart pulse rate is to be monitored, the timing of the pulse is more important. The flow of blood volume is decided by the rate of heart pulse, and since light is absorbed by blood, the signal pulses are equivalent to the heartbeat pulses. A humidity sensor senses the measures and reports the relative humidity in the air. It therefore measures both moisture and air temperature. Relative humidity is the ratio of the actual moisture in the air to the highest amount of moisture that can be held at the air temperature. The warmer the air temperature is, the more moisture it can hold. Humidity or dew sensors use capacitive measurement, which relies on electrical capacitance. Electrical capacity is the ability of two nearby electrical conductors to create an electrical field between them. The sensor is composed of two metal plates and contains a non-conductive polymer film between them. This film collects moisture from the air, which causes the voltage between the two plates to change. These volumes changes are converted into digital reading, showing the levels of moisture in the air. This is Arduino board. Power cable. Every Arduino board needs a way to be connected to a power source. The Arduino Uno can be powered from a USB cable coming from your computer or a wall power supply that is terminated in a barrel jack. In the picture above, the USB connection is labeled and the above barrel jack is labeled. Pins. Ground pin. Short GND, which is the short for ground. There are several ground pins in the Arduino board, any of which can be used to connect to the power. 5V and 3.3V. The 5V pin supplies 5 volts of power and the 3.3V pin supplies the 3.3 volts of power. Analog signals are connected through the pin number 6. And these digital input and outputs are connected to the pin number 7. Humidity sensor. The water content in the air is measured using the term is known as humidity. The amount of water content in the air is really an important parameter as it affects the human conflicts. Various physical and chemical and biological processes are most likely to depend on the amount of water content in the atmosphere. Temperature sensor. Temperature sensor has the 3 terminals and 5.5 voltage supply is the maximum voltage for this. The material in the sensor performs the operation which depends on the temperature to make the changes in the resistance. The sensor senses that changes in the resistance and temperature is calculated. The increase in the voltage makes the temperature to increase and this operation is monitored by using diode. Temperature sensors can be connected directly to the input of the microprocessor and the sensor is also capable of providing the reliable and direct communication with microprocessor. Heartbeat sensor. The principle behind the sensor is photothyesomography. It is an instrument which measures the changes in the volume of blood with help of any particular organ. Since the blood volume majorly depends on the pulse rate of the heart, and by this way it can be detected that that is healthy or not. Light emitting device emits the light which passes through the vascular region, something like an earlobe, and the detector receives all the signal. The light emitting diode of the heartbeat sensor, such as photodiode, light from the source of the light will reflect the light in the case of a finger tissue and transmits the light in the case of the earlobe. The light detector receives the processed light. The volume of the blood depends on the amount of light observed. Gas sensor. The gas sensor consists of steel exoskeleton under which a sensing element is placed. The element under exoskeleton will be subjected to current. With the help of the connecting leads, presence of any gases will ionize the sensing elements which causes the changes in the resisting of the sensing element. Gas sensor has high sensitivity and fast response time and the sensitivity of the gas is adjusted by the potentiometer. Basic workflow. The sensors are connected to the coal miner's helmet and the data from the sensors is connected to the Arduino Uno and the UNO gives the information to the Lifi transmitter. The Lifi transmitter transmits the data from the UNO wirelessly to the light medium. These data are received by the Lifi receiver, which in turn is connected to the Arduino UNO. That Arduino UNO is connected to the receiver end. Methodology. The sensor network which consists of the various sensors like humidity sensor, temperature sensor, gas sensor, heartbeat sensor gets the information from the miner in the form of analog signals. The heartbeat sensor gets the information in the form of digital signal. The data are transmitted through the Lifi transmitter fitted in the helmet, and the informations are received by the Lifi receiver at the another end. This is our finished helmet at the coal miner's side, which is equipped with the 4 kind of sensors and the Arduino UNO and the Lifi transmitter. At the receiver side, we have that Lifi receiver, which is connected to the Arduino UNO and which in turn connected to the receiver end. Conclusion. A real-time monitoring system is developed to provide a clearer and more point-to-point perspective of the underground mine. This work will be helpful to all miners inside the mine to save their life before any casualty occurs. Improved data transmission will be achieved using Lifi. These are our references. Thank you.